in flowers like sunflowers. The contaminants bypass the roots and get locked heavily into the stems and leaves. And that's the biomass. Now, the thing that's really interesting here is it's saying many flowers process biological barriers that actively restrict these toxins, the toxic isotopes, from entering the seeds or flower heads to protect the next generation. However, if the plant dies naturally, it rots on the ground, releasing the radioactive particles back into the topsoil in a continuous loop.
Okay.
That's interesting.
That
So the
is,
seed is protected. What you're saying, I think, is
Mhm.
that there's a biological process where the radioactive stuff doesn't go into the next generation. But the rotting of the parent plant, okay, so it would only be seeds that were taken and carried to a new location that would grow up healthy. Is that right?
That's what it seems like to me.
Okay, interesting.
And what you call that? Methane. Well, you know, in the car,
Yes.
oxygen and methane. You know how trees absorbs that up.
Methane. Trees
does
absorb methane.
Yeah, does it affect that less of it, or brings it to where the tree don't produce as much, or well, what would be the case of that?
Well, what I found out from this is it says that when scientists use flowers for cleanup, they must harvest the green plants before they drop seeds, because the radioactive plants are then incinerated under extreme containment for safety process into the glassy solid called vitrified waste for deep burial.
Goodness gracious me.
No, hold up, I got that wrong. That last part is then incinerated under extreme containment, or they're safely processed into a glassy solid called vitrified waste, and that's for deep burial.
Like when you, what would happen when you bury, when you take peanut seeds and you grow them in the soil? You hear about how it pulls to put hydrogen, oxygen back into the soil. Would that still work on that situation?
I don't know. I mean, like now you're talking about peanuts and shit.
Well, I was referring to about the thing about how it works with the soil, like it brings.
Do you know if peanuts actually do anything when it comes to radiation, or are you just kind of like?
Well, I don't know if the decrease or however peanut was, what happens to peanuts, I don't know. I thought either way. I just know that peanuts put oxygen back into the soil.
Peanuts put nitrogen into the soil.
Yeah.
Peanuts put nitrogen into the soil.
They said that peanuts have been extensively used in radiation research and soil cleanup experiments, but scientists discovered they react very differently than sunflowers because peanuts are a major global food source and grow their own pods directly underground. Researchers have heavily studied how the interaction of radiation, soil, and heavy metals and radiation induce mutations.
Right.
So
they're trying to see if the process by which the peanuts put nitrogen into the soil can be used somehow to clean the soil. Is that what the gist of the research is?
Yeah, apparently that they were using it with Fukushima the Fukushima nuclear research. And that's peanuts versus cesium.
Cesium.
And following the Fukushima nuclear accident, Japanese agricultural scientists conducted a comparative study on radioactive cesium transfer in peanuts and soybeans. Now, because the peanuts developed their fruit, which is the pod, underground, scientists feared they would absorb massive amounts of radioactive cesium-137.
I see. Oh, I see. Okay.
Directly through the shell. Now, surprisingly, the research proved that the peanuts are highly resistant to absorbing radiocesium.
Okay.
The peanut plant has a natural biological barrier that severely restricts the translocation of cesium from the roots up to the stems and from the stems into the actual peanut fruit. So
Good heavens.
So the study the study concluded that peanuts accumulate significantly less radiation cesium in their seeds than soybeans grown in the exact same radioactive soil. Applying potassium to the soil further blocked the peanut from taking in the radiation. So,
gosh, so peanuts are naturally resistant to radiation. Now, cesium. So, what was it in the sunflower? What was the sunflower resistant to? Was it also cesium?
Now, the sunflower, let me see, I've got that one up here. This one is actually the first one that Robert had me go through. I'm having to scroll up. Scroll up, Roger.
Scroll up.
Okay. Let me see here. I didn't realize how far I'd scrolled up. Now it says here that the chemical imposter, I believe that was the one where, okay. It says when nuclear disaster occurs, the radiation itself doesn't physically settle anywhere. Rather, no, that's after that, I believe.
Yeah, it was around there.
With all them plants, the bacteria, you know how they say you gotta switch up
you're asking too much questions. You're just I'm still trying to answer one of the questions.
Sorry.
You said, yeah.
Sorry about that.
You're like already into asking another question and stuff. Yeah, the sunflower. Yeah, you're right. It's no, when scientists use flowers to clean up, they harvest the green plants. That's
right. Right.
Okay. Now, was that in the notes? Yeah, there. That could have actually been in the notes. Plants growing in highly contaminated areas often, no. Yeah, here it is. It's some plants act as biological vacuums. Sunflowers were deployed at Chernobyl because they naturally absorbed radioactive isotopes like cesium-137 and strontium-90. Now, because these isotopes mimic essential nutrients, potassium and calcium, the sunflower suck them from the soil and water and lock them into their own biomass without dying. So they lock them into that biomass, which is the trunk and everything, without dying. So the peanut, I guess, has a resistance where the sunflower just sucks them in there and keeps them.
Sucks them in. Yeah, that's amazing. What a
Yeah, so you
miracle.
could say you could plant sunflower on one side and peanuts on the other, and the two would work towards each other as goals.
Well, I would probably use peanuts for like if you're a farmer living in an area that was affected by radiation, which there are people who do that. They still live
Mm.
there. You know, like
Mm.
in Japan, um, I would probably grow peanuts so that I could have something freaking sell.
Well, yeah,
Yes, something that you can eat that's not poisoned.
Right.
Whereas the
yeah.
sunflower's cleaning your environment. But it's not really cleaning your environment unless you pick the green matter and take it and go and burn it in some huge factory thing and make some glass stuff out of it and then bury it in the soil. I mean, so it's kind of a not just it's no good unless you do the whole
Well, I was wondering too.
destruction thing.
Now, there's one more thing on here that
Mm.
goes into the notes that I underneath the sunflowers, and they call it cosmic radiation mutagenesis. They said joint research by the IAEA and the FAO involves sending crop seeds into space to expose them to extreme cosmic radiation. This intentionally triggers rapid DNA mutations to cultivate new supercrops that can resist climate-driven drought and extreme heat. So I figured I'd throw that out there too.
Mm.
What about like the garden that's growing up high up in the mountains? You know, the heat or radiation or however they say.
Well,
You know,
It's
the
a
mountains,
different type of radiation altogether.
yeah.
and
You
and
know
besides that, with mountains in radioactive situations, they always encourage people to be around the mountains because there's some mountains even that has like minerals inside of it that can protect you from the fallout. So I mean, that from what I remember them saying that it was
Mm.
safer for you to be in a mountain region whenever it came to nuclear fallout rather than being on flat
Okay.
ground.
Gosh.
But that was old school stuff. That was back when
Mm.
Cold War was going on and everybody was terrified of it.
But I think that there's two different types of radiation that we're talking about here. There's radiation, which is the transmission of heat and light from the sun to Earth. And then there's radiation that comes from radioactive material.
Mm-hmm.
And it's very confusing because we're using the same word for two different things.
Right.
You do get what the geographers call radiation of different levels, which means that up high in the mountains, because the air is thinner, more rays from the sun can penetrate. And so you can actually get more of the sun's radiation to Earth at the upper levels of the atmosphere.
That's what I was referring to.
Yes, but those are balanced by the fact that it gets colder the higher you go. So you need that extra input from the sun to sort of balance out the temperature there a bit. Whereas down low, where the atmosphere is thicker and heavier, more of the rays from the sun get blocked and get bounced back out of the atmosphere, and so they don't reach the actual ground.